I'll just illustrate what can be done with control sources. As I said, they are models for more complicated circuits, but here I'll just show you that some other elements that we know can be synthesized using control sources, okay, or their values can be altered and so on. Now let's consider a resistor. We know that the voltage across the resistor and the current through the resistor are related by Ohm's law, okay, and the constant of proportionality is the resistance. Now let's consider this picture where a voltage V is applied to the resistor and that causes a current I equals V by R or V times G. Okay. Now, if we think of this picture, we think of the voltage resulting in a current or the voltage controlling the current. Okay. We have already discussed a control source which accomplishes this function, that is controlling a current using a voltage. That is a voltage controlled current source. Okay. So what happens in that case if we take a voltage controlled current source? There is a certain voltage Vx, and let me define this to be Gm times Vx. So what it says is, if I apply if I apply a voltage V here, a current Gm times V will flow over there. Okay. What does a resistor do? If a V is applied across it, it draws a current I, which is V times G, from the voltage source itself. And that scenario can be easily arranged in this picture, right? This Gm times V, I could have connected this to any circuit. Now I'll choose to connect it back to my circuit. Okay. So what happens? This Gm times V will flow here and it will actually flow from this voltage source. Okay. So the current flowing out of the voltage source is Gm times V. Okay. Now if you consider the circuit within this boundary, that is between these two terminals, what do you see? As far as this voltage source is concerned, when it's connected to this particular circuit, it draws a current Gm times V. That is, it draws a current proportional to the voltage. So from those two terminals, you cannot distinguish this from a resistor. Okay. So this entire circuit inside here is equivalent to a resistor, and its conductance is given by Gm, which is the proportionality constant of the voltage controlled current source, or equivalently its resistance is given by 1 by Gm. Okay. So what do we have here really? We have a voltage controlled current source, and the controlled current is connected back to the controlling terminals. Okay. So we end up with a two terminal element. There are only these two terminals, and between these terminals there is a linear relationship between current and voltage. That's because of the linearity of the control source. Okay. So this entire arrangement just looks like a resistor, right? So you can take a control source and synthesize a resistor from it. Okay. So if you think of a resistor, it has two terminals, and there is a relationship between the voltage across those two terminals and the current flowing through the terminals. If you look at a voltage controlled current source, the controlling voltage and the control current are at two different pairs of terminals, but we can always connect them together to form a resistor. Okay. So this is something useful to remember, that a voltage controlled current source connected back on itself behaves like a resistor, and you can find the resistance value. Now, as some of you would have guessed already, we could also use the other picture, that is, we can think of a resistor as responding to a current I to produce a voltage V equals IR across it. Okay. So now if we think of this picture with control sources, we need a current controlled voltage source. Okay. There is a certain current Ix. This will produce a voltage which is Rm times Ix between these terminals. Okay. Now what do I want to realize a resistor? Let's say I have a current I. I must sense this current, that is, I must place this controlling branch in series with this. So I will show it like this. This is Ix and this is the controlling branch, and this current must flow through that, and I want the voltage between these two to be proportional to the current. Okay. And here I have the voltage between these 2 points to be proportional to the current Ix. Okay. So what do? I just place the controlled branch in series with this whole thing. Okay. Now this schematic looks unnecessarily complicated, but that shows the thought process, right? I sense the current and then I have this voltage which is proportional to the current. So I place it in series with this branch, which is a short circuit, so that across these two terminals, now I have a voltage which is Rm times Ix, which is equal to I. Okay. So clearly, like before, if I look at this equivalent two terminal element, okay, so it will look like a resistor, and the value of the resistance is Rm. Okay. So you can use a current controlled voltage source also to synthesize a resistor. Okay. So this you will find useful later when you are able to implement control sources using active elements like transistors. You will be able to realize a variety of functions, okay, which may not be physically possible very easily, but you will be able to do this. Okay. I will show one example of it soon, but there will be lots of examples where you can realize exotic VI characteristics using control sources. Now this schematic looks very complicated. The way I would normally draw it is simply show a controlled voltage source whose value is Rm times Ix, and I label Ix here. So obviously, if I drive this with a current I across this, I will have Rm times Ix. Okay. Now, just as one example of exotic stuff that is not possible with physical elements, but you can realize using control sources, is this. We already saw that connecting a voltage controlled current source like this, that is Vx, Gm times Vx, realizes a conductance equal to Gm, or a resistance which is 1 by Gm between these two terminals. Let me call these A and B. It will look like a resistor. Okay. Now one thing is that a physical resistor is constrained to have a positive resistance. Okay, that is, it always dissipates power. We look at those aspects later. Whereas resistance synthesized using control sources can equally well be negative. Okay. Negative resistance, and in this particular arrangement we need Gm to be less than 0. In that case it realizes a negative resistance. So another way to think about it is that, let's say you had a controlled source Gm prime times Vx, and Gm prime happened to be more than 0. Okay. Still we can realize a negative resistance. All we have to do is to connect this here and this over there. Okay. Then if I connect a voltage source V, a current Gm times V will flow there, a current Gm times V will flow there. So we can see that the current direction is like this if you trace it around the circuit, where this Gm prime is a positive number. Okay. So that corresponds to a negative resistance. If you have a positive resistance and a positive voltage V, what it means is that the current will flow in this direction. Okay. Now if this resistance is smaller than 0, that is, if the resistance is negative, then the current will flow in that direction. Okay. The current in that direction will be positive. It will push the current back into the voltage source, and that's what a negative resistance does. Okay. So that's one example of exotic things that can be synthesized using control sources.